Hi everyone, I'm Miss Davis. I'm a 4th grade science teacher and I love doing hands-on projects. So today I'm going to walk you through a hands-on science project that you can do at home that will help with this week's science lesson. But before we begin, I want to note that the CDC's guidelines for staying safe in the COVID-19 pandemic were used while filming this video. Please make sure that you too are following those guidelines and staying safe. All right, let's do some science. Hey everybody, this week we're learning all about waves, and so we're going to do a couple of science projects to demonstrate how sound waves work. But first, remember, we have to keep our clean space. So I am going to clean off my work surface with some bleach spray. Okay, today we're going to explore sound waves. So we're going to start with a couple of projects that you can do at home. I have just a regular glass bowl or a cup. I have a balloon. You can see I cut the bottom off of the balloon and just have the top of it stretched very, very tight over the cup. It acts like a little drum. That's cool. Then I have some plastic wrap to go over my bowl. What you're going to want to do is take the plastic wrap and pull it very, very, very tightly over the bowl, like as tight as you can possibly get it. And if you can't do it just having it stick, because you know what, sometimes plastic wrap is the worst, then we're going to add a rubber band later that'll probably help. So we get the plastic pulled nice and tight over the bowl, and then I'm not going to use the rubber band because mine is tight, but if you have one and you need to help keep your plastic wrap in place, just put a rubber band right around the bowl just like this to help it stay in its spot. Okay? Then what we want to do is we want to put something on top of the balloon or the plastic wrap so that we can see the sound waves. We know that sound is energy that is caused by vibrations, and it makes waves. We can't see the sound waves when we're speaking or when music is playing, but they're there. So there are some things that we can use to help us actually see the sound that's happening right here. So I'm going to use grains of rice or salt. I'm going to try the salt on the balloon first. And I'm going to put a little bit of rice on the bowl. Now, before you do this, make sure that you're not going to make a mess, because I don't know if you're going to want to have to sweep rice and salt off the floor. So maybe you need a little something like this, a pan. And you could put your bowl or your cup into a pan so that when the salt and the rice go everywhere, it doesn't make a hard mess to clean up. Now what you can do is start experimenting with the sound of your voice and see if you can make the rice or the salt dance like this. That didn't work. That was ugly. Ooh, it really danced there. Let's try the salt. Well, see, be careful because you might just blow it all off the balloon. Yeah, that doesn't work so well, but that's okay. That's why we have the pan to catch the salt and more salt from the shaker. So I'm going to use a piece called Rhapsody in Blue by a composer named Gershwin. So I'm going to play this as loud as my phone can go and hold it right by the bowl or right by the balloon and see if that will make the rice or the salt dance. So watch really closely. Here we go. It's starting. Okay, so you can try this at home too. I would say use salt or rice, but just know that rice is really heavy and it's a lot harder to make the rice dance than the salt. So you might have both. But get up and sing, try some different music, see if high-pitched music or low-pitched music works better. Come up with a hypothesis before you get started and see what you can find out. Hey guys, just a quick note that the 2 demonstrations that you are about to see were filmed in fall of 2019 in my classroom, so no concerns about the pandemic then. Here we go. In this video, you're going to see a wave model that will show us both amplitude and wavelength of a wave. So what I did was take skewers and I put a gummy bear on each end. Yes, I did eat a lot of gummy bears in the making of this wave model. Then we evenly spaced those skewers out on a piece of duct tape and put duct tape on top so it keeps everything in its place. Then when it's time to demonstrate the waves, we clamped each end of the model to a chair so that it's suspended mid-air. So you can see it suspended here. Miss Arms applies pressure or gives it energy, and you can see that wave travel from one end to another. Focus on one gummy bear and watch how high and low it travels. That's your amplitude. Then you can try to see how long it takes to get from one peak to another, or how many skewers it takes to get from one peak to another, and that is your wavelength. Here it is in slow motion. You can notice as it travels that it's starting to lose energy, and so the amplitudes get smaller and the wavelengths get bigger as it takes longer for a wave to travel from one side to another. In this video, Miss Arms and I both apply pressure from each end of the wavelength model, and you'll see how they collide in the middle, a lot like a Newton's cradle. And then as time goes on and energy lessens, it all just kind of shakes. Here's the slow motion. You can see right there in the middle that the waves hit each other and then continue to move through the model. Isn't that really cool? So sound waves actually work in a similar way. Low sounds create long wavelengths, whereas high sounds create really, really short wavelengths. In order to change the amplitude in sound, we have to change the volume. So if we turn the volume up, we get a bigger amplitude, and if we turn the volume down, we get a smaller amplitude. Pretty cool, huh? Okay, let me explain what you're about to see in this video. So what we did was take a non-Newtonian fluid that you might know as oobleck, which is just cornstarch and water. But the cool thing about it being non-Newtonian is that it is both a solid and a liquid at the same time, which is perfect for this experiment. So what we wanted to see was how sound energy is transferring into this oobleck. So we took a big stereo speaker and laid it on its side, and we covered it in plastic wrap so that the speaker itself wouldn't be damaged by the oobleck. And then I found some deep sleep music, which is a very, very low frequency, which means it has a lot of bass or low sounds to it. So you'll notice we put the oobleck in the biggest circle of the speaker, which is where the bass part of the music is produced. You'll see what it does. It's so cool. You'll also notice in one of the speaker wells, I did not have the proper mixture of non-Newtonian, so it couldn't turn solid, but you can still see the sound waves there. It's pretty cool. Check it out.
What if we add more? Now that we've kind of figured out, oh my gosh.
Okay, so to recap what's happening in this video, the energy or the vibrations that are being created by that sound are transferring into the oobleck, or that non-Newtonian fluid, and making it dance around. So you can see the vibrations of the sound. Super cool, right? All right, thanks for joining me for this week's Hands-on Science project. I hope you had fun and enjoyed your science and learned a lot in the process. I will see you next week for more science. Bye!
Yeah, this is
Are we
right.
on? Hello?
We're on.
I'll do a close-up. Not that. Happy science! Sing. Make some hypotheses.